All right, ladies and gentlemen, we are nearing the end here. We are going to start a couple of sections in Chapter 15, a couple of sections in Chapter 14 before we wrap stuff up for the semester. So for this one, we're going to start talking about some algebraic postulates here that we're going to then see how we apply them in geometry. So this is a good kind of summary of some of the geometry concepts and review and intro back into algebra as we get ready for Algebra 2 next year. In our 5 postulates we're going to study today, the first one is fairly straightforward. If you have 2 real numbers, x and y, basically any numbers that are not the same, then one of these 3 statements has to be true. One's less than the other, they're equal, or that same one's greater than the other. There's no in between. The next postulate states that if A is greater than B and B is greater than C, then we know A must be greater than C, and vice versa with less than. So think about anything in our number system. If we had 1 is less than 2 and 2 is less than 3, well, we can conclude that 1 must be less than 3. So that's our transitive property. We did that a lot during first semester. That applies with inequalities as well here. The next postulate, if A is greater than B, then if you add something to A, you add the exact same thing to B, your relationship doesn't change. So 2 is greater than 1. So if I add 5 to this, I get 7. Add 5, I get 6. 7 is still greater than 6. That doesn't change my property. The multiplication properties, there's 2 of them because you got to differentiate between when A is positive and when A is negative. So to understand that, we look at an example as, say, something like 2 is less than 4. If x is 2 and y is 4. Now if I multiply by a value that is greater than 0, all that's telling me is I'm a number that's positive. It doesn't have to be an integer. I can multiply by 1/2 on both sides. If I take 1/2 times 2 and 1/2 times 4, I still am going to have this same relationship. I'm going to get 1 is less than 2, and that relationship still holds. However, if I multiply by a negative, so instead of by a 1/2, I multiply by a -2, let's say. Now let's say I multiply both sides of this ratio, and I'll use the same values, 2 and 4. If I have -2 times 2 and -2 times 4, the relationship between these variables, or between these values, is now different. -2 times 2 is -4. -2 times 4 is -8. Well, -8 is now less. So it started with x being less than y, or 2 being less than 4, and after I multiplied by a negative, my inequality switches. It's these 5 postulates that we are going to implement and use as we move through the lesson today. So we start with the idea of supplementary angles again. So if we have a given angle is greater than twice its supplement, if I call the given angle x, then its supplement must be 180 minus x. Then continuing to mark my text here, is greater than is the greater than symbol, and when it says twice, it means it's 2 times this. So my inequality I can write from this is that x is greater than 2 times the quantity of 180 minus x. Find the possible measures of the given angle. I want to know what are the restrictions on x. So I can use my algebra skills to solve this. When I solve this algebraically, we get x is greater than 120 degrees, but remember, we're dealing with an angle that has a supplement, so there's also a second restriction. My variable, or my angle x, still has to be less than 180 degrees, but it also can be greater, or has to be greater than 120 degrees. Those are my restrictions on x. In example 2, find all values of x for which the angle with measure 5x plus 40 will be obtuse. So now, for an angle to be obtuse, it has to be greater than 90 degrees and less than 180 degrees. That's going to be the measure of my angle. Since I know the angle has a measure of 5x plus 40, I can take that 5x plus 40 and set it less than the 180 degrees, and at the same time greater than the 90 degrees. And again, algebraically, solve for x. If you haven't done it, press pause, solve for x. So in this case, x would have to be greater than 10 and less than 28. On the next side, example 3, you might need to sketch this out to kind of get a better handle of this, or it might become obvious to you as you read through what they're asking. So go ahead and try example 3. Try all A, B, and C. Press pause. See if you can come up with relationships. So part A is hopefully a little bit more straightforward. X is between P and Q, so Px has to be less than PQ. If it's somewhere in between the whole thing, then it has to be less, length has to be less than the length of the entire thing. A key part of part B is the idea that they want this as an inequality. So sure, because x is the midpoint, we know Px is equal to half of PQ, but the inequality that represents is that it's less than PQ. How much less? Exactly 1/2 less. But for an inequality, we don't need exact equation. We want the inequality symbol. So for part C, using the situation in part B, write the relationship as an equality. Well, that's what we have right here. It's exactly 1/2. And with that said, it's certainly possible for you to write that as 2px equals pq. Either one of those would be perfectly acceptable. All right, now we're going to get into something that can be a little bit trickier. X is twice y and y is 3 times z. How is x related to z? See if you can come up with some ideas to kind of compare x, y, and z in this, and then unpause to see how you did. In this case, we see the words is, so these are not inequalities, these are equations. If it said it's greater than or is less than, then we have inequalities. The word is without the additions of less than, greater than, is going to mean it's an equation. So we can show the algebraic work that x is equal to 6z, but one thing that we're going to need to get used to as we finish off the semester is we're going to both show things algebraically and write out what that means. Write out the words that that represents. It represents that x is 6 times the value of z. We're going to kind of give both algebraic and written descriptions for a lot of things as we move over the last few days of the semester here. All right, if you haven't done it already, then make sure you take a look at numbers 5 and 6. These can be a little bit trickier, so go ahead and give this one a try here for number 5. I'm going to pause mine, put just the first step on there, kind of give you an opportunity to process it, then the next step, give you an opportunity to process it, and then I'll show you the answer. All right, so here's the first steps you should take. You have one that's already got y isolated. I'm going to isolate y in my other inequality. See if you can come up with some kind of relationship you see here. All right, so what we need to recognize is that y is less than 1/3 x minus 11/3, but y is also greater than 8 minus 5x. So this is part of that transitive property we talked about. I already have that y. I can create that relationship right there. I didn't change anything. All I did was write both inequalities here, which means I can conclude that 1/3 x minus 11/3 is greater than 8 minus 5x. That's the transitive property of inequalities. Now I have an inequality with only x. We can finish solving this. Go ahead and make sure you finish solving for your values of x. So from here, if we multiply both sides by 3, we don't change the inequality relationship. Solve for x. We know that our x value has to be greater than 35/16, which means if I substitute that back in, the y value has to be greater than negative 2.9375 and at the same time less than that. Now we're going to say this is all real numbers, because if it's greater than and less than the same number, the only time it would have been equal to that number is if x was equal to 35/16. X can't be 35/16 because it's not equal to. Y is all real numbers. On our graphing calculator, that's how I type this in to get my values. And we also could graph this and see the intersection points. And if we did do that, and I did, but I'm not going to necessarily display it, what we would have seen is that's my y-axis and that's my x-axis. My solution set would have been looking like this. My x values are greater than 35/16, and my y values would have been all real numbers, because that both lines are either increasing or decreasing forever. And for the last one, don't overthink it. Angle A is angle 1 plus angle 2, so angle A has to be greater than angle 2. Angle 2 is made up, or angle A is made up of angle 2. As part of it, it has to be the bigger of the two values. All right, ladies and gentlemen, those are our angle relationships. There's some pretty complicated homework problems that are going to allow you to practice some of this, and I'm going to attach that as a worksheet. I want you guys to go ahead and work on that. I will be posting an answer key to the worksheet, but I might just do answers only and then offer you an opportunity to send me emails, ask me questions. I will ask that you complete the worksheet and submit it to me. Take care, everybody, and I hope everybody's doing well.